Well, hello all, and welcome to the second showing of our exciting webinar today on preparing LiDAR data to use and share. My name is Dale Lutz. I'm one of the co-founders here at Save Software, and I'm joined today by
Dmitry Bob. Hello, everyone.
And Dmitry, you are a scenario specialist here. That means Dmitry gets to play with all the stuff, but you come to us from many years of experience actually in this industry using the kinds of data we'll be talking about today.
Yes, exactly. I'm a professional FME gamer.
Wonderful. And helping us out with today's Q&A, we have Steve McCabe, Product Support Specialist at Safe. Say hi to everybody, Steve.
Hello, everyone. Thanks for taking time to join us this afternoon.
So everybody out there, your job is to keep Steve's fingers typing away as we're off and running here throughout our time. So before we begin, I should just double check, Steve. Do you think it's all clear this morning? We didn't have audio for our exciting introduction.
Yeah, we've got all clear there from our
all clear from our control booth.
technical. Yep,
That's
right.
wonderful. So actually, I should just say before we get going that it is International Women's Day today, and so just thank you all for taking time out to tune in. Our friends in Australia, you've missed your chance at International Women's Day because it's already tomorrow there. So, but there's no reason why you can't pretend that it is. However, that would change your behavior. So here at Safe Software, our goal really is to take and remove the burden that different data formats and file formats and data models impose upon data practitioners everywhere. When we started the company back in '93, the common knowledge was that, or the common story was that 80% of any GIS project, the time was spent, 80% of the time was spent preparing and gathering the data. And really what a terrible shame that is, because only 20% of the time then is spent really doing what you need to be doing with that data. And our goal is to take that initial 80% of the time, the fights you have with data, and squeeze it down to nearly no time at all so that you can spend your time, or your users can spend their time doing what it is they need to be doing so they can make better decisions and do their work in a faster, more efficient, more productive way. And so that's really our goal. And after a couple years of doing consulting at SAFE, in about 1996, this thing that's called FME was born, and since grown far beyond what we could have ever imagined. But FME is a product that sits in the middle and brokers and transforms data between all these different data formats that we are working with. So I thought we would get to know you all just a little bit by first of all asking our first poll question of the day, about asking you, how much do you use FME, or do you know what it is? And so if you can chime in on that, we'll just get a sense of our audience so we know how fast or slow to go. Now for those that aren't familiar with FME at all, there are introductory webinars to FME that are run every, I think every couple of weeks, and at the end we'll have some links to those to show you. So we got a very good voter turnout, much higher than we normally. Oh, look at that! It's a great great bunch this afternoon. Thank you all for being so engaged with us. All right, I'm going to close the poll there, and we'll share the results. And over half of you don't use FME at all, and so to you I say thank you so much for tuning in. We do appreciate your time, and we hope that in the next 55 minutes or so we can give you a taste of how the technology that we've created hopefully can help you slay the data dragon and let you be more productive with your data. In our case today, particularly LiDAR and point cloud data. Okay, so with that, well, since over half of you actually aren't familiar with FME or don't use it, FME is this product that sits in the middle between a wide variety of different data formats and provides you the ability to convert those formats from one format to the other, but more importantly to rearrange the data on the way through so that when it gets to the destination it is exactly what you want. You can also integrate data, bringing data from a variety of different formats together. And lastly, why would you want to do this? Well, one reason is you might want to share data that you have with others. And you can do this by using something that we call FME Server, which we'll get to at the very, very end of today's thing. Most of today I'm going to spend using our FME desktop product, which consists of a few pieces. Anything you do on the desktop can, in fact, be pushed to a server if you need to upgrade to that kind of capability, and we'll touch on that at the end. So FME is this machine, this software that sits between all these different formats. In the beginning it was CAD and GIS. Over the years we've added rasters and databases, 3D and BIM, XML, which Don Murray, my co-founder, loves very much. Any of you that, if you love XML, you can visit our archive, webinar archive, and you can see many of his things there. And of course point clouds, which is the purpose of today's webinar. And most of the work that we do in FME is done inside or authored inside of this graphical data flow environment that we call Workbench. And you're going to see me using this to piece together or to route data from wherever it is, in our case it would be LiDAR data, to wherever we want it to be, possibly LiDAR data, possibly other things, along the way doing these blue things which are transformations. And we will not spend a lot of time looking at how those transformations take place. We will show you what kinds of things, what kinds of problems you can solve. If you want to dig into those things, I'd suggest you sign up for some of the intro webinars, or we also do online trainings. And in fact, a little spoiler here, at the end we'll be having a draw where you can enter to win a seat at a future online training. Okay. Well, it's time for the first demo. So let's get going here and take a look. Okay. Look at that. I got software update from these guys. I don't think I want that. But what I do want is to look at this directory that some friend has given me of a bunch of XYZ files. Actually, we're talking to Australians probably, so I might be allowed to say XYZ this afternoon. To all of you out in the British Empire, XYZ files. But in most of North America, we call them XYZ files. So I got a whole directory of these things, and this morning when we took one of our polls, we found that a lot of folks actually do deal with point cloud data in ASCII form, which is a shame because it's a pretty clunky form, but nonetheless easy enough to understand and deal with. And I suppose over the years people wrote software to work with it. So this has a bunch of files. They're all structured the same with a bunch of numbers here, X, Y, Z, and intensity. And I want to work with them in FME. So if I want to do that, the first thing we always recommend is know your data first. So I looked at it in Notepad. The next thing I'm going to do, we have part of FME on the desktop includes what we call a data inspector or nearly universal viewer type of technology. And so that lets me take and drag this guy on here. And I'm going to just check the parameters. It says that, yes, the file has field names, and it has a mapping from the column names to the XYZ components that we want to have inside of our resulting point cloud. Everything looks pretty good there. But I do want to go ahead and do all of these at once. I'm just going to go Control A and open them all at once. And let's just take a peek at what we got. And there, oh, there it is. It looks good to me. I'll put this into 3D mode, and we'll just spin it around a little bit. I think it looks like it's in 3D. We can just zoom in here. Yep. I think that's great. And we can actually even go and pick on a point and see its X and Y, and I'll just make this a little bigger here for us. Yep, we can see the Z as well. So that's great. We know what this is. We got what we started with. But what I've been told is that our job today is to prep this data for someone who wants this ultimately in a LASZ file, an LASZ file. And it's in XYZ right now. We want it in LASZ. So what are we going to do? Well, let's fire up the Workbench product, the Workbench part of FME, which is our, oh, look at it advertises that there's a webinar today. In fact, I think probably it's not upcoming. It's actually happening right now. So if people are out there seeing it just right now for the first time, it's probably a little later. They could try to sign in. But anyway, what we do is we drag this into here. And again, we say, let's tell it that we're interested in all of them. And I can actually use an asterisk there or wildcards as well if I feel like it. So now I've got these point clouds. And what I really want to do is to make LASZ files. So I'm just going to add a writer here, LASZ, whoops, LASZ, yep. And I'm going to put it, let's see, into my output directory, which is conveniently empty. And we can adjust parameters. Let's go with 1.2 is as good as any, Dimitri?
Yes.
And we won't do anything else here. All right. And it asks me would I like to add a new feature type. Yes. I'm going to go ahead and say that it's picture type called project. And actually, no, I need to leave that shooting them out because I'm going to just go and make one output file for every input file. And so there I've got my translation configured, and I'm going to hit run. And it does its thing. There's really nothing as exciting as watching this log go by, wouldn't you say?
As long as you don't see any red lines, everything okay.
That's right. So there it says it's done. Tells me it wrote out 20 point clouds. So 20 were read here. And if I right-click on this and say open containing folder of the output, sure enough, I have a directory of LASZ files. And because we are paid to be skeptical, I will go and just take a quick peek at these guys inside of the data inspector. And I'm going to try my hand at using the wildcard here of asterisk. And there they are. They all, wow, they load up fast. And I guess that's because it's a lot faster to grind through a binary format like LASZ than it is to grind through some ASCII things. So mission accomplished. Our first task of the day looks like it's gone well. And so we'll go back to our webinar. Okay. So yeah, that gives you a little taste of where we're headed in our time today. But what I thought we would next do is find out from you what are the end goals ultimately that you have with LiDAR and point cloud data in your organization. So let's get this poll going here. And you can choose as many as you want. We really want to understand better how folks out there make use of point cloud data so that we can adjust our products to make them the best possible. We did have folks this morning, some that were doing archaeology, some that were using it to look at facilities like power lines and road center lines and things like that, forest volumes, some of the other things that were done, crime scene investigation. In fact, someone this morning wrote in and said that they were responsible for selling the first ever sale of LiDAR capture to police in North America. So they can go on site and capture the scene, and then later on, when their Sherlocks, their virtual Sherlocks are working in their office, they can then adjust things at that time and make measurements and so on. So we'll close the polls there and let you all see those results. So again, lots of people doing surface stuff. Oh, we have some archaeologists again this afternoon. Maybe they're going to find Atlantis. I know that there's at least some people that think that Atlantis is in some swamps in Spain as a result of looking at LiDAR data. But anyway, there you go. So thank you very much for that input. So I thought we'd now now that we know the kind of things you want to accomplish, what are some of the roadblocks that might be in your way as you try to deal with LiDAR data? And I thought to set the stage for that, we should spend a moment or two reflecting upon the good old days of Raster. Raster formats have been around with us forever, good remote sensing things, but they have a lot of nice properties, not the least of which is that they're very regularly spaced. So if you want to find out what's the color of the pixel right on top of the Safe Software Office and you've got a raster, you can do a little tiny bit of math and you can figure that out. If you want to just carve that raster up into pieces, it's very simple. Let's just take the first 6 rows and the first 6 columns and give those to one file and so on and so on. So a lot of things are very easily dealt with in rasters, remotely sensed but still easily dealt with. What I like to say is that point clouds are really rasters gone wild. They're a little bit out of control. They share some characteristics, but they impose a lot of other hardship upon end users. And the first one is the massive data volumes. Now, Dimitri, in some of the testing you've been doing, can you give us a sense of the magnitude of some of the files that you've been playing with?
Well, some of the mobile LiDAR files we received from our customers or partners exceed 1 billion point, 1.2 billion points, and the file size is over 40 gigabytes.
40 gigabytes. I almost feel like doing a Dr. Evil here, over 1 billion points. But yes, it's a lot of data. When we started out 18 years ago, a large data set would fit on a floppy disk. Now we have to be mailing hard drives around to help share that. So this can be an issue. If you have to deal with that, if you have to archive it, if you have to distribute it, if you have to bring it into software, not too many software packages are happy with 1 billion points at a time. Would you say, Dimitri?
Yeah.
Yeah. So that's one of the issues. The points are irregularly spaced, which means you don't know what you have for coverage. In this scene here, down at the bottom, we've got areas where there's nothing and other areas where it's quite dense. So there's no real rhyme or reason. You've got a whole bunch of points there, and they're just wherever. And to top it off, for any given x and y, you could have multiple z's. So you have possibly many readings at one x and y location, and you don't know how many readings. In this example, you'll get one bouncing off the leaf, one at the branch here, maybe one here, and then down at the shrub, and then finally the ground. And so these are what we call multiple returns. And so at any given return, we also can have a lot of components, we call them. So is there an angle? Is there a classification code? This one actually had one of 5. What flight line was it? What was the intensity? And in the intensity, we have the added thing that those sometimes go from 0 to 256 or 0 to 65536. Isn't that right?
Usually to 0 to 255.
Yes, okay, 255, sorry. And sometimes there's RGB on these things as well. In modern times, there's a color. But we don't know. You could be dealing with any of these things at any time, and so that adds to the fun. Okay. And the other thing that's interesting is that it may not be that it was captured from overhead. It could have been captured by driving around and scanning things from the side. And that's kind of interesting as well because it affects the density. It affects, you could get points that are way far away from where you're interested in. If there was a bird flying off in the distance, you might get a reflection back from that. So all of these things can make our data sets have bigger footprints than we need and more data than we really care about. So, as someone once said, what is to be done? Well, hopefully we have a set of solutions for you today that can help erase some of the challenges that you may be having or may run into when dealing with data of this nature. And so what we're going to do is, first of all, ask you some questions or a question about what kind of workflows you tend to have to do in your daily business as you try to accomplish your goals with LiDAR. So we've got a few things there for you to choose from. And so there we go. Well, a lot of people looking surfaces off to an early start. And tiling. Dimitri's a big fan of tiling, I know. Reprojecting. We have a special announcement about reprojecting coming up later on in the webinar. So you'll want to tune in for that, hang in there for that. Boy, this is a really heavily surface-oriented crowd today, isn't it? Almost everybody is wanting to do surfaces, so we'll let that go another second or two. Okay, and close. And so you can take a peek at what folks are interested in. So clipping, cropping, all that sort of stuff, very popular, but surfaces overwhelmingly, and actually a lot of folks that just need to do a plain old translation. So I think you're going to find that we are going to cover almost all of those today, and hopefully you'll see some things that might give you some ideas about how you can use this to smooth your workflows. So the first thing is translate, and that really was what my quick demo just did. Of course, we can translate raster and vector formats over and integrate, but in terms of point clouds, of course, the ASCII, which was our example, we have Oracle Spatial, point tools, if folks out there are using that, and LASZ, all those things are in FME 2012. And so when we're doing, for example, LASZ, we support up to 1.2. Folks this morning were asking about 1.3 and 1.4. I know that we intentionally didn't do 1.3 because we'd heard that it was not widely used. If anybody out there is a really big 1.3 fan or has workflows that would need that, please send in a question right now about that to let us know your interest. Otherwise, we probably won't do that. 1.4 just got finalized. I have a hunch we will do 1.4 eventually. Again, if that's important to you, please send us a chat about that too. But the one thing I wanted to point out was this business of the LASZ compression or LASZ. And that is an open source compressor written by a gentleman named, really a genius guy named Martin Eisenberg from Germany, who's made it available for all to use. and you can look up lasszip.org if you want the details and find out who's using it. But if you have FME, it's pretty darn easy to invoke it. And so I'm going to go ahead and do that. Right, before I do that, Dimitri's got a good, actually, I just leave these files there because the other ones are going to end up with a new extension, and then we can compare them. But just to give an idea, this is the kind of file sizes we got for our little example here. And I'm going to go over here to our output and just tell it, yeah, you know what, let's compress the files. Just like that, and I run it again, and that beautiful symphony that is the log file goes rolling by, and I'll look at our output directory, and now we've got LASZ files, and let's just take a little look. If we start them, we should see, and I never tried this at home first, so I am very thankful that the LASZ file is bigger than the LASZ. So that is good news, because if it wasn't, we wouldn't be very happy. Now, there's not a huge compression going on here, and there's a few reasons for that. These are very tiny files, so it doesn't really get a chance to really pay off. But nonetheless, it seems like it made a difference there. And actually, we can once again, if we want to view them, let me go and just go and drag the LAZs into here. So let's look at all the LAZs. So let's do star.LAZ. Bang, there it is. And again, not too surprising, it's identical to what we had before. So that's with us compressing it all and getting some reductions. Now, how big of reductions can you expect? Dimitri, I think this was a color example.
Yes, these are the color LASZ files. And as you can see, it's about 2.5 times smaller than the original LASZ files.
Yes, and this one is?
These ones don't have color, they have only intensities. So in this case, you see them 4 to 5 times smaller than before. So if we have scan ID
yes.
component, then we can sort by it and then compress and get even bigger compression.
That's right. We've learned from Martin, the author of the compression, that actually a lot of times the compression that our little examples here are seeing is actually much less than what you get with typical data sets hot off the scanner or otherwise sorted in the right way. So he often sees up to 1/10 the resulting size when he does his compressions. So anyway, that's the LASZ compression. Certainly good if you're going to be sharing data. Even if you get it to half or a quarter the size, that's 40 gig down to 10 gig, and that's a significant savings. A gig here, a gig there, it does tend to add up, and especially if you're sitting there waiting for it to copy or send. So one of the things we pride ourselves at SAFE about is on the formats that we do support. And so we are curious, what formats do you use out there? Now, we are working on FME 2013 right now, and the E57 format is something we're underway with. So if you are interested in E57, please let us know that. Oracle Spatial, we do that. We're actually pretty proud. We can load 1 billion points at a single run into Oracle Spatial. Not a lot of things can do that, and we will build the index externally. So anybody interested in trying that out, we'd love to get feedback from customers. So please send in a question right now if you're interested in working with us on taking the Oracle Spatial point cloud for a spin. And I see a number of you do use it, or at least have expressed interest, so that's great as well. We're also adding TerraSolid, Rigel, and I think ZFS is the other one. If any of those are things that you're interested in, please send a question in right now just to register that you're interested in those. And when we get Rigel, ZFS, or TerraSolid into FME, we'll let you know. E57, if you'd like to try that out, I think that's in our beta. We can connect you with that too. Send a question in right now if you're interested in that. So let's look at the results here. You can see ASCII overwhelmingly the leader, so there's a lot of ASCII out there. We do a great job reading it and writing it. A lot of folks this afternoon doing Oracle Spatial, so that's great to see as well. And some interested in E57 too, so thanks very much for that. All right, well, we like to say it's safe. You can't really do a good job moving data if you don't know what you're doing, and so we've added the ability to at least inspect point clouds in our data inspector. And I think, you know, Dimitri, you've done a lot of work, but wouldn't you agree that it's pretty crucial to be able to snoop and see what's in the point cloud independent of format.
Yeah, I'm glad we added coloring of the point cloud so that you can easily see how the elevations are distributed.
Right. So this is when this example, this screenshot, if the point cloud comes in and there is no color information, we will do a color ramp like this, right?
Yes.
Yes. So that was one of Dimitri's requests, and I'm glad we listened to him. Reprojection. Well, it's very easy to reproject data inside FME, and so I'll just I won't actually do a translation with it, but if we were going to reproject it, we could just click here and say reproject, pop that in, hit the button, and say, okay, we're going to go from Ohio N or whatever it would be to UTM, sure, and then we fill it in, and off it would go and do its thing. One of the interesting things that we've added recently is we support ECEF. Whoops, how do I get to it? Earth Center, geocentric. Geocentric? Yeah, there it is. Geocentric. And so that's basically measuring from the center of the Earth, because some LiDAR connections are like that, or LiDAR files are like that. So we can do a reprojection very simply. This morning somebody asked if they have Z values that are in centimeters, can we scale them? And what was the answer, Dimitri?
Well, just use a scalar transformer. Keep X and Y at 1,
right,
and use your scaling factor
0.254 or whatever it is, or 0.001 or whatever you need to do.
Yeah. And
that would do the trick for that. So that's that kind of a situation. Okay. Yeah, and we talked about geocentric. We also do some orthometric height support for North America. That's at the bottom here, NAD 27 heights and NAD 83 heights. But now you can see the kind of thing that Dimitri has created using this technique to go from something that, what was this, lat long to begin with?
It was just a rectangle covering the Earth and lat long, and an image, JPEG image, which converted to a point cloud and brought to geocentric coordinates.
And then this was made into PDF or something, or was this in our viewer?
It was in our viewer.
Oh, very good. So that's that kind of technology. But now we have something that I know you've all been waiting for, and that's the announcement of the new iPad. Actually, no, that was actually yesterday, wasn't it? So no, that isn't what you're waiting for, but this is an announcement. We made it this morning. We'll make it again today. A lot of folks have asked us for this for a long time, and this is as exciting as when Sonny and Cher were reunited on stage back in 1987, December, I believe, on the David Letterman show. And what is that? That is that Blue Marble and SAFE are working together to bring the Blue Marble reprojection technology, which for many companies is the gold standard, and make that available inside of FME workflows. And so if that's of interest to any of you, please send a question in right now, and we'll make sure we'll connect you with our friends at Blue Marble, and they will get you involved in beta testing this. So you can see how this is shaking out. We've allowed or created some APIs so they can extend our user interface to integrate their very, very thorough support of coordinate systems worldwide. And I personally am very excited about it. I know my Blue Marble friends have asked if it's like Sonny and Cher on stage together, who's Sonny and who's Cher? And I'm not thinking, I don't think I'm going to answer that. But I do know that I can do a pretty good, I got you, babe. So that's where I'm going to go. And there's no auto-tuning at all. That was me. No auto-tuning. Dimitri's holding his hands over his head. Okay, tiling. So this is a very common thing, chopping up a scene into smaller pieces. There's really two ways of accomplishing this. You can do it by clipping a bunch of rectangles or using a transformer called tiler. So Dimitri, do you have any advice or comments about the tiling operation?
Well, tiling is not only convenient for making smaller pieces and shipping them, but it's also very useful transformer to improve performance. You can tile your data set into smaller pieces, perform some operation, and combine your data back. So I really hope that the numbers for using tiler will grow up by the
Right.
end of this presentation.
Right, right. Very good. So tiling, clipping. So basically, let's take a vector of some kind and carve out a chunk. And in this example, I guess you were doing a buffer around the roadway. Is that what was going on?
Yes.
Yes. And what do we use to do that?
Clipper.
Yes. And you know what? Should we go and add that to our example? Because I think what we were told, I'm kind of letting the requirements dribble out, but what we were told by our client for our little example here, not only were they unhappy with getting XYZ files, they also didn't want the whole area. They just wanted stuff for their project site. So let's again take a look at our data first. And this is just a MicroStation design file with a nice little polygon in it. And that's the area that we care about. And so that's great. So at least I know what that is. So I'm going to take and drag that into my workspace here that I was working on. And now we got ourselves, good. So we got ourselves our clipping area. And I'm going to pop down a clipper. And for those that don't know FME, these transformations are all available in this transformation gallery down on the side here that lists all of them. And we have documents that show you can browse and make wonderful airplane reading to kind of flip through the transformer catalog. The good news and the bad news is that there's lots of these transformers. I think there's close to 500 now. And so part of the power of FME is that you can do almost anything, but one of the problems is finding the transformers that you might want. And so we've added searching capabilities here. So if I say clip, here's anything that has something to do with clipping, and I can take and drag this out. Once you start to know your way around FME, you can just type in here and start typing clip. Oh, point cloud Z clipper. That must be a custom transformer.
Yes, that's mine. Yeah.
Okay, good. That's available on our FME store, and one could download that and see. So anyway, I've got a clipper here, and what I want to do is I want to take and I'm going to put these point clouds in as clippies, and I'm going to connect that boundary as the clipper, and the things that are inside or cut and inside, I'm going to take and route them to my output. Now I better empty out my output directory because I don't, let's see, here we go. Yeah, let's make it empty. We're good. We're running. So now we're going to read that design file, use its boundary, clip the 20 or so point clouds, and what we see is that actually 5 of them were totally inside and 14 were cut. We started with 20. That means one of those original point cloud tiles got chucked entirely. So these numbers are very useful in understanding what's going on when you do your translation. So let's take a look in our output directory now. And yes, we have LASZ files. We're still compressing. So I'm going to grab my friendly neighborhood data inspector, and we'll just take a quick peek. Whoops, that's a bit unnecessary. Okay, let's do this. There they are. And I'm going to just go and get the asterisk for this, and we'll grab them all. And there, oh, they changed shape. So that means that the clip must have worked. Yes. Okay, so that's good news. And now you've seen clipping. So this is some scenarios that Dimitri was working on. These were 1 billion point files that were captured by, I think it's called terrestrial LiDAR, right?
Mobile.
Mobile, yes. And so what were you doing with these?
Well, basically 1 billion points is a manageable file size, so we try to clip and tile it into smaller pieces which are easily manageable.
So on the left was imposing a grid of tiles over the whole thing,
yes,
and then chopping up into smaller pieces, and on the right basically was buffering the capture track.
Trajectory, yeah, of the capture track, and making, I think, 100-meter pieces along the trajectory.
Yes.
Yeah.
So we get 1 point cloud out on the right-hand side. Is that right?
Yeah, maybe these pictures.
Yes.
Just
yes.
One piece.
1. So we'll reveal the performance numbers a bit later, but that's the kind of things that you can do. Oh, and this is something that Dimitri's been experimenting with lately. Can you run us through this?
Yeah, this is a very simple filtering technique. In FME 2012, we added true 3D clipping. So basically here I replaced the source point cloud with stacks of small boxes, and then I analyze how many points fall into each box, and then based giving some criteria, say if I have more than 5,000 points per box, then it's something very dense and probably it's ground. So, and as you can see, it worked quite well to filter out the road surface.
And this is another one that, so this is the before.
Just the bigger one.
Yeah.
Yeah.
And there we go after.
Yeah.
Yes. So these are the kind of things, and we've done this sort of thing to get rid of birds out of scenes and
filtering clouds, yeah.
Yeah, debris and so on. Thinning. What would we do to basically reduce? This is when you want to throw away data. It's just there's too much, and for the purpose that you're doing, perhaps you're just working on a workflow. You want to reduce the volume and so on. Point cloud thinner.
Yeah. For example, if you need an overview point cloud covering the whole county or a city, then you can leave out. Just keep every 10th or 100th points.
Yes.
Point to reduce the file size, but still keep the representation.
Yes. Okay, surface modeling. So we can actually go ahead, and many of people on this call were interested in that. So let's go give that a spin, and let's see how that goes. So this one here is going to ask us to make a surface model out of this, and to do that, I can do something we call a tin generator. Does that sound right, Dimitri?
Yep.
And so I'm going to make a tin or a surface model. I'll take these point clouds and put them in as points for that. And that point would have a surface, but really that surface doesn't do me a lot of good. What am I going to do with it? I can maybe route it other places. I can make a DEM out of this and so on. But for today, I would like to actually write this to a 3D PDF. How does that sound? So I have to add a writer, 3D PDF. And we'll go into this place, call it, I'm going to name it after you this afternoon, Dimitri. Okay, Dimitri.pdf. Yes, and we're going to call this our project area. All right, and so that's the PDF, but I could put the surface there, but that would be boring because it would be nicer if we would drape an image over this thing. And the good news was that we did have, in our input directory, an image here, which I could just quickly take a peek at, because again, we should always look at our data first just to make sure we believe it. Yep, it's a nice image, just like any other kind of image. Good. All right, so let's drag that image in. It's a JPEG 2000. It's going to form part of our input. And there it is. And what I'm going to do is duplicate this. And I'm going to clip that image also to my clipping area. So I'm just going to have the part of the image that I care about. And now I'm going to overlay the image onto that tin. And we do that with something we call an appearance adder. So let's take this guy, put him here. The image for the front is the clipped inside part. And I want the tin surface to be my geometry. There we go. So that's going to add the appearance. And then I'm going to just take the resulting surface and put it out to my PDF. And, whoops, with any luck at all, when I run this, it's going to work. Do you think it's going to work, Dimitri?
I hope so. It has my name.
Okay, so here's the moment of truth. It's making the PDF right now. A lot of folks don't know any Acrobat Reader newer than version 7, I think, can do a 3D PDF. We recommend version 9 or 10. It's done, did its thing. So in the output directory, with any luck whatsoever, I should see Dimitri's name. And there it is. And so now I'm going to just haul it over. I don't have Acrobat right there, but I'm going to put it over on my virtual machine's desktop. I'll paste that. Back on the Mac side, wipe over here. Let's find the Finder. Whoops, where's my Finder? And I'll get a new window here. Let's go to my desktop. And where is it? Here we go. And Dimitri should be here. Yes. Okay. And with any luck, we'll see. Oh, there it is. And if we flip it and turn it around, it works. And we like to say that we can have anyone, and I have to, this is no joking, when I was rehearsing this last night, I actually had my mother-in-law on her computer using 3D PDF. Seriously, that is not a lie. It's really true. And so anybody can use these, and so it's a very handy way to gain more value. See, in this scenario that we're creating, not only are we going to end up sending LASS files to our end consumer of this data for the product area, but as a bonus, we're giving them an overview PDF so they can better quickly understand what's going on in that area. Okay, well, I'm relieved that that worked just fine. And that was, I guess we did it with the tin generator, so that was a good thing. There's a DEM generator as well and a contour generator. These are other things that are in FME that can help work with these.
Yeah, they are all the subsets of the surface modeler, the more general transformer.
Right, there's one called Surface Modeler that does it all. And so here's an example that you did. This one was with 250 million points?
Yes.
Yes.
We were able to generate DM in about 2 hours.
Yes. Okay, combining. Well, see, the other thing that I didn't mention, or I should have, is that our customer doesn't want a whole bunch of LASS files. They want just one. And so let's take a look here at my output directory again. I'm going to clean it out. Whoops. And delete it. Whoa, that's not what I wanted. So I want to do this to get rid of it. Empty output directory. And they just wanted one output file. So I need to combine all these point clouds into one. And I could do that in many different places in this workflow. But I'm going to do it, I don't know, where do you think I should do it, Dimitri? At the end or the beginning? What's your preference?
Well, we probably won't see any difference, so let's put it before QP.
Before, okay. So if I click on that line and I say Point Cloud Combiner, or PCC, I can do camel case if I know my shortcuts. There I go. And so basically, that's going to join that whole thing into one. And so if I run this again, let's do this. What we'll see is that 20 of them are going to go in there, and one will come out. And it does it in a very, very fast way. And we'll end up with only one output guy at the very end. And so it's making the PDF again. Let's just take a look in the output directory while we're going. And there it is. Oh, I forgot to name it properly, because now we don't want to fan out or name them after what they were originally. I'm just going to call them project. So we'll run it again, and I'll clean out that thing. So that isn't what it's going to create. Yeah, and so you can get the idea. The Point Cloud Combiner takes many and makes one. And there we go. Okay, so that's good. Actually, I just wanted to take a look here. Yeah, 20 went in and one came out. Very good. Okay. So combine, yeah, Point Cloud Combiner. Now, Dimitri, what are some of these scenarios about?
Well, we can combine not only point clouds, we can combine any geometry. We can take rasters, we can take vector geometries, 3D geometries, and make them into point clouds. So this is a real scene with fake cars on the street. So they were taken from a SketchUp model and colored and turned into point clouds.
Yes, so we can do that. And this morning, actually, there were some customers interested in this. This example, was this one SketchUp to point cloud?
Yeah, yeah.
Yeah, and
so 3D warehouse.
Right. So if for some reason that's more useful to you, you can do that kind of thing. Okay. Okay. Point cloud splitting. Can you give us some ideas of why you might do this, Dimitri?
Well, we may want to split point clouds by, say, return to separate canopy from the ground, or we can split by class to separate water from vegetation, from ground, from buildings, if your data has classification.
Yes. And recently we've added this capability.
Yeah, this was a customer request. So for everyone, that's a great way getting new functionalities. Send us a request, what you would like to achieve, and we will try to implement it. The customer wanted to extract road marking from their LiDAR data. For example, extract yellow from the road surface or white. And we added splitting by color and intensity ranges.
Yes. And so here's some of the kinds of results.
Yeah, so as you can see, yellow stands out on gray color. So it is quite easy to classify and separate yellow. And after that, after a few manipulations, we can turn them into polygons.
Yes. And then this is a similar kind of example with white.
Yes, yeah. The examples are a little bit different, but basically, yeah.
And this was actual customer data coming in, I think, from our friends in Quebec.
Yes, yeah.
Right. So interesting things that can be done. We wouldn't say that FME is a perfect feature extractor, but for some kinds of problems with the right kind of ingenuity, you can definitely glean some value very quickly and easily to get you at least a starting point, a start of the way to a solution. Colorization. You know, we've seen it done on movies, but now we can do it to point clouds. Take an old black and white and add color to it. You know, I think one of the movies that won an Oscar this year had no sound at all. And so I'm wondering maybe they could do the same sort of thing and actually add sound back into that movie. Just think how good it would be if it had sound. What do you think about that, Steve?
That's an interesting idea.
Yeah, I'm wondering. So anyway, we can take and colorize point clouds. And why don't we go ahead and look here how that typically works. You run in a raster into a point, this thing here, and a point cloud as well, and out comes something colored. So, and we get this type of examples coming from one that had no color to one that did. And I think is this next one from our friends in Langley?
Yes.
Here it is. Finally, the Township of Langley, I don't know if there's anybody there tuning in, but they provided us a whole pile of their data, and we have been working with it, and they've teased us that we've never shown it. Well, here it is. And actually, my kid's school is just down the road from here somewhere, but this is in the middle of Langley, and it was an uncolored point cloud combined with
also imagery
and resulting in this. So why don't we try that back in our example here. Now, let me see. I can actually tell that now I don't need this line that's going here from the inside, so I can actually get rid of that. And I know that right here is my uncolored point cloud, and so I'm going to just go ahead and this point, if I highlight it and I say point cloud on raster, up it comes, and there we go, and I'm going to go and grab this image and put it in as my raster. I don't think I need to really do anything here. It's automatically set up. If we wanted to do something better than nearest neighbor, we could. But I'll just leave it nearest neighbor for now. And we'll output it to our project. And I will run this again. Oh, I should have disabled the PDF. But while it's thinking, I'll fire up my data inspector. And I'll take a peek at my output directory. And let's just take a little look. How are we doing for time here? Oh, it's writing its PDF. Good, it's done. So let's go back here, back here, back here. This thing here, compressed, but with luck, in color. And we'll find out, oh, am I ever relieved and happy? It is in color. And so there we go. And I think now, as far as my little example goes, we've met our needs. We've colorized this thing. We've gave them an overview PDF. We've got it in one file. We would be done our project with that workspace that we created. So that ends that, and I think that ends our talk of colorization. This one here, Dmitry, do you want to just talk briefly about extents calculation?
Well, as our experiments show, there is a lot of data around that don't have lots of files don't have correct extents in their header, especially along z-axis. So, and that causes sometimes for our visualizer it causes problems. Coloring them correctly, you would see just bluish or greenish or reddish colors, but for some software it causes real problems.
Yes, and so that's why we've added this ability. If you run it through, we will update that metadata.
Yes.
That's right. And as Don says, he's never met a data he hasn't liked, and so we'll just let that one go with that. ArcGIS 10.1, for those that don't know, has good support for LiDAR LASZ files in it. If you have the 10.1 beta, you've probably played with that. We're pleased to say that FME is ready to take advantage of that. When 10.1 comes out, we can create for you the .LASD, the LASZ dataset files. You need those if you want to go like that to view LASZ files in ArcGIS. You can't just point at LASZ files. You need this little directory file, the LASD. If you run it through FME, if you have ArcGIS present, we will create the LASD file for you. And that's what you get when you see it in ArcMap very shortly thereafter. Some people call these LSD files, and after you see this picture, you might tend to agree. So for our last example that we're going to show today is a profiling and slicing example. Can you run us through this one, Dimitri?
Oh, this is a small reconstruction project. We have some LASZ data, road center lines imagery. We would like to give to our engineers some data along the road, some slices of point clouds, so they can do their project.
So I'm going to just fire up the example here, and I guess the idea is that you create some lines that are perpendicular to the road.
Yes.
And then kind of buffer that.
Yeah.
Go ahead and then.
Yeah, we make those perpendicular lines, buffer them, and they can have really high density of points. You don't care that the entire point cloud was big. So smaller pieces, but with really high density, can be delivered to engineers.
Right. So we end up with this this example here. So let's just try to zoom in a couple of times. There we go. Right. And so if I start turning things off, let's turn off the original LiDAR, and we'll turn off the project zone. Oh, we start to see those profiles starting to appear. We can turn off and on the roads. This is the reconstruction project Dimitri was mentioning. And that's the perpendicular lines for the, you can see the little red flipping off and on. But if I now look at the various slices that we've got, I can turn those off and on, but more interestingly, let's take and spin this around. And so we can kind of see what's going on in the region of our road above the project. So that's again, you might output this in LASZ files or in point tools or in other things to be used later on down the stream by your workers. So this lets us again work with much smaller subsets than the whole mess of the LiDAR, and yet accomplish our goals very much more quickly. And so you've seen the kind of thing that we can do there. So just a little bit about performance. You want to talk to this at all, Dimitri? What kind of machine was it that you were running on?
Well, I have four cores, 4 GB of memory, 64-bit Windows XP machine. It is not new. I think it's 2 or 3 years old.
Yes. So you can see these kind of numbers. We also can do parallel processing inside of FME, and if you're interested in exploring that, Dimitri's found some scenarios that are as much as 5 times faster on his computer. Visit this fme.ly/parallel. There's a technical article there all about that. Lastly, I just wanted to mention that all the things we've shown today on the desktop can be pushed up to the server, where you can run them in an automated way, in a centralized way. People can trigger them through web requests, web forms, that sort of thing, or even by sending email. And so I invite you right now, everybody out there, go ahead and send an email to lidar@dondemo.safe.com. That is an FME server running in the cloud on EC2, Amazon EC2. And we've set it up so that when you send to that, and the message can have nothing in it, what it's going to do is make you your very own special PDF that has your name in it. So when it comes back, you'll need to have Acrobat Reader to do that. So please give it a try. And you know, we're not charging anything. These are free PDFs, and you all get your own. What a great take-home takeaway from today's webinar, and you'll see how that works. And so it'll take a few seconds for it to come back, but go ahead and give that a spin. And this is just an example of the kind of thing. We're doing other experiments where we're mailing in images, and we can get things coming back. That's a new area that we're experimenting with FME Server. Traditionally, FME Server is more of a clip, zip, and ship sort of thing. And this is an example of the architecture. The one you're hitting has only got 2 processing engines. But Steve, you work with FME Server stuff. What was the largest FME Server installation you're aware of?
The one with around 56 engines is going to go up to, and the one prior to that, 28 engines, and I think there's a few other in between there that I...
Right. So that means they can process that volume of things in parallel across many different machines all at one time. So in a case like this, if all of you out there hit it at once, each one's going to take about 3 seconds on average. So it may take a few minutes until everybody gets through, but nonetheless, it would scale. And this is the kind of thing you're going to get. When I did it last night, you can see my name wrapped there. And this is actually what my mother-in-law did. She emailed into that and got back a 3D PDF and was quite impressed. You'll need Acrobat Reader, though, to see it. So to wrap up, I know we're just about at the top of the hour. I hope you've seen today how FME can help you prepare and use and share your LiDAR data in a very quick and fast and efficient way. So as we wrap up, again, send in any questions if you have any, and Steve's standing by for those. But I thought we'd one last time just see that now that you've seen what's possible, what might you imagine using out of the technology that we showed you today in your daily work? So let's just see, and be interesting to notice if anything changed there. And let's see. Yeah, a lot more, I think more people are interested in doing tiling now. Everybody likes tiling once they see how easy it can be done. And yeah, that's the big winner. This morning, tiling was the big winner as well. So thank you very much. I hope this has helped you imagine how you can get your jobs done more quickly and efficiently and really make more use of your LiDAR data. So many customers we've bumped into have this stuff, just can't use it because, as Gene Rowe of LiDAR News said to me once, traditionally the data had the power over the people. With tools like this, we hope we give you the power over the data so you can put it in its place. So we'll close that poll, show you the results just for a moment. As you can see, tiling going to be popular. If you have suggestions how we can make that even better for you, fire that into us, and we'll carry on. Now, if some of you are new to FME, I know half of you are, there is a weekly intro webinar you can tune into, so fme.ly/intro. All these links will be mailed to you later. On FMEpedia, there's a bunch of LiDAR-related articles that you can go and see, and we have a bunch of upcoming webinars as well. If you enjoyed this and some of these topics tweak you, this is Google Fusion Tables, very interesting technology as well. So there's that. Oh, it's time for us to do our exciting draw. And I'm just about ready here with our exciting music that we use when we do the draw. What is the draw for? If you want to take any FME training course, you have to register. If you win this, you got to register by the end of March, but you can attend any time this year. And you can view the whole course catalog at fme.ly/online. And you have to just let us know if you'd like to see that. And I've got to play the music. Here we go. So this is our exciting music. So that's right, a few more seconds, a few more bars of the music. Who's the composer again, Dimitri?
It's Uran.
And what nationality?
Wow, Armenian.
Armenian, okay. I didn't even know that before today. I think that the voting is ended, so we can turn off Khachaturian. And thank you very much for that, and we'll be in touch later. So we're at the top of the hour. If there are any questions that you've got, Steve, I'll just ask you, was there any pattern to the questions today so far? What did you notice out there?
We had a few requests for certain formats. This one person is going XYZ to 12D Genio files on a regular basis. Another person, TerraScan.
Yes, that one we're working on. But we want to be in touch and get them the beta. That'll soon be in there.
Okay. And we've got a couple asking particular workflows like intensity information from a point cloud to a raster base, application codes.
Yeah, can do that.
And another one, can I translate XYZ to a geotiff tiles?
Yeah, Dimitri says yes.
Okay.
So those are good questions, and we'll be following up with all of you. If you ask questions that Steve wasn't quite able to get to in the next day or two, we'll be following up as well.
And an honorable mention to someone who did go out with the girls for International Women's Day.
Yes, very good. So I just, again, if you're a guy out there, you got in North America anyway, a few more hours for Women's Day to do something about it. And if you're a woman, well, sit back and see if the guys deliver anything in light of that day, at least if there's any time left. And if it's in Australia, you've got, I guess, 364 days to figure out your plan for next year. So the archive, I think we're going to go with this one. What do you say, Steve? Is this a better one than the morning session?
I think so, yeah. We weren't so rushed at the beginning with our technical difficulties.
Right. So thanks for tuning in on the second one. The jokes maybe weren't just as sharp. You know, when it's the second time, it's hard to recapture that spontaneity.
That is very true.
Yes.
Yeah.
But other than that, we'll add it to our 8-track archive. That could be a Sonny and Cher tape, actually. Anybody out there know who Sonny and Cher were? And actually, I offered this morning. Nobody knew. If anybody knows what radio phone-in show in Alberta used to use the music that I was playing for our contest, our draw, if you can name that, I'll send you a T-shirt. And you've got to be probably 40 years old or older and grew up in Alberta. And actually, most of the people I talked to around here didn't even know who Sonny and Cher were either. So I might need to update my cultural references. Yes, we'll be sending you an email with directions to find the archives of today and all the links from the thing today. So that'll be coming soon to you as well. And so I think that's about it from our side. Thanks so much for tuning in and for hanging in there till the end. Steve and Dimitri and I will hang around here in case there's any questions that you still want to ask us through the question mechanism. But other than that, we'll bid you adieu. So that's it for me.
Yep, that's it. Thank you very much for attending.
Yeah, thank you everyone. Happy International Women's Day.
Yes. Okay, and so with that, we're going to end the broadcast. Thank you so much.